Okay, I'm going to start the series on crankshaft grinding by giving an overview of the machine and some of the challenges that come with doing a good job on a crankshaft. This is my machine. It's a Winona Van Norman, which was actually built in Italy, imported, as most manufacturers in the US did starting in the 80s as our manufacturing base declined further and further. But it's a real good machine. I've owned it since new. Grinds great. It essentially is two chucks, one on each end, and this end is the end that is powered, the wheel head side, and it of course just rotates. Right now it's on centers, but when we come to grind the rod journals, I'll actually be moving it on these slides to the correct offset for the stroke, and that's how a crankshaft is ground on the rod journals, is by offsetting the chucks. I'll show you that when we come to grind the crank. Now, one of the first things, one of the most important things, is to match the radius on the crank to the radius on your wheel. Now, this is a radius gauge, and it has all different sizes of radius, both an external and then an internal, and you have to try to get the camera right here. How well you can see that, but this is the radius on a crank. This section right in here, you can see that's a rounded area. That's where the strength of any crankshaft is the radius. If it's too sharp right there, it's a stress riser, and in use that crank can break. You know, not as important on a little four-cylinder, but making any power, you really need to have a good radius. So as you can see, the radius I've selected in my gauge matches that perfectly. It's a 3/32 radius. So I have to select a wheel, crank wheel, that has the correct radius and is the correct width. Now, unfortunately, this is a perfect example of why grinding crankshafts is a pain. Of course, the main journals are narrower, so if I wanted to change the wheel once and use the same wheel for rods and mains, I'd have to get a wheel that, you know, obviously is no wider than this main. Unfortunately, like I say, the wheel that's on here now would fit the bill. It would do both. It's a little narrow, but the radius is too big. It's got a big radius on it, so that won't work. So I have to select, out of my selection of wheels, one that will do both. Now, this wheel right here happens to be the perfect width for both, and it has the correct radius on it, 3/32. This doesn't always happen. However, coming back over to our crankshaft, don't know how well this shows up, but on the mains, the radius, it's half of what it is on the rod throws. It measures a little less than a 1/16. And you have to look at all the mains, because sometimes you'll have one that it'll have a much smaller radius, and that determines what you can put on it for a radius. You can't add radius, you can subtract radius, but most of the time they're consistent, but not always, and this is a perfect example. So I can't use the same wheel to do rod journals and main journals. So after I grind the rod journals, which you have to do first, you can never grind the mains first on a crank. You always have to grind rod journals first, and so I'll have to, take extra time to pull the wheel off and put another one on to do the mains. And it's just an example of very time consuming to do a crank correctly. I could bang right through this in no time and take the radius right off the crank and, make good money, but that's not the correct way to do it. So that's one of the challenges that comes with grinding a crank. This is the control panel. It's very simple. It's still a hand operated machine. Got an in-feed wheel and a wheel for the table. CNC hasn't really come into a shop like mine, aftermarket shops. In production, they have CNC machines that use like a CBN wheel, but it's still a traditional vitrified stone wheel. And my next video, I'll actually mount the crank and show how we get the the strokes offset to the correct diameter or the correct length, and I'll show you a few more items.